Okay, this is the second worksheet in 7.1, area between two curves with respect to y. Um, Hopefully, the voice is a little clearer than my first attempt. I think the second worksheet or the second attempt went okay. Um, Sorry again that I'm not there today. Uh, I am at home. Both my girls are sick, and both of them have ear infections, double ear infection, and pink eye. So that's what we're dealing with at home. So fun stuff. But hopefully this helps as you guys are figuring out your 7.1 material. Okay, we talked about in the earlier video when it's with respect to x, it's going to be top minus bottom, and then left and right. But with y, it's a little bit different. So when we're dealing with area in terms of y, okay, it's going to be the integral from the bottom most y value to the top most y value. And then it's going to be right function minus left function. Remember, this is with respect to y. Okay, so I've already done a sketch graph of each one of these just to give you an idea. Probably the easiest way to get these sketches are to use Desmos, because Desmos will graph any functions, whether they're in terms of x or in terms of y, or however you want to graph them. That's your prerogative. You do what you got to do. Okay. So in this instance, we are looking at this area right here. And so really I need to come up with that y value and that y value. So you can set those two equal to each other. And, I'll do the first one first, and then I'll just kind of tell you what the boundaries are, and you can try them on your own. But if you want to try and find the boundaries, you just do y squared equals y plus 2. So it's going to be y squared minus y minus 2 equals 0. And then just factor that. So that's going to be y minus 2 and y plus 1 equals 0. So we're looking at y equals 2 and y equals negative 1. And that makes sense. That's going to be negative 1. That's going to be 2. So our integral is going to be from negative 1 to 2. And then our rightmost function is the linear. So we're looking at the y plus 2 minus the leftmost, which is going to be our parabola, y squared, with respect to y. Plug that into your calculator and you should get, 4.5 or 9 halves. Okay. Looking at the second one, okay, it's very similar. Looking to this one, just things are kind of flipped. We're still looking at this area right here, okay? But our boundaries in this case, it's kind of like shifted up one from the previous one and then flipped. You're actually going to get the same answer. Your area here, and again, I should probably put area since we're going to be talking about volume in the next section. Area equals our bottommost y value, which is right here. It's the origin, 0. And then our top is going to be 3. Probably hear my daughter crying in the background there. She's not feeling too hot. Our rightmost is going to be our quadratic looking graph. So it's going to be y times 2 minus y. And then this is going to be minus and negative y. So it's really going to be plus y dy. And it actually ends up being 4.5 again. Okay. Here we're looking at the y squared plus 1, which is right here. We're also looking at, in this case, this is going to be like x equals 0. So you're looking at this right here, and then y equals negative 1 and y equals 2. So we're looking at this entire area right here. So our boundaries are already given to us right there and there. Okay, that's going to be integral from negative 1 to 2. And then you just do the rightmost function, leftmost function. So the rightmost function is going to be your y squared plus 1 minus 0 dy. And in this case, that ends up becoming 6. If you really want to get into the habit, it's up to you. Since we're dealing with area, it's units squared. It's not that big of a deal when we don't have a story to go along with it. But again, we're going to do some application problems, I think, at the end of this worksheet. So there might be some, units that we can put in with it. All right. Here is our y over the square root of 16 minus y squared. And then this is just our y equals 3, and then x equals 0. So we're looking at this little area right there. Okay. Looking at the boundaries, we're looking at 0 here, and this line is y equals 3, so it's going to go from 0 to 3. And then it's just going to be right minus left, so you're really just going to have this equation minus 0. So if you want to just write that, you can go ahead and do that. Don't forget your variable of integration. It's just a little notation. It's just a little detail, but we definitely need that because we don't want to have this be dx because these are in terms of y. So remember, whatever this is, your integrand needs to be the same thing as far as the variable components. Plugging this into your calculator, you should get approximately 1.354. Okay. If you want to pause it, obviously, and practice plugging stuff like this into your calculator, I would suggest doing that. I've had plenty of practice over the years, so I kind of just go with whatever the answer is because I trust what I've done before. But hey, prove me wrong. I love being proven wrong if I don't have the right answer. Okay. Looking at all 4 of these equations, it's what is enclosed by those 4 equations. Well, this is my 10 divided by x. This is my x equals 0. This is my y equals 2. And this is my y equals 10. So we're talking about this area right here. And so that's going to be the boundaries 2 to 10. And then your rightmost function minus your leftmost. Well, in these instances, it's going to look similar to like a disk method. If some of you have worked ahead and looked at the washer and disks when you're flush against what we're talking about, but this is just going to be 10 over x. Well, hold on 1 second. Got something wrong here. Let me wipe that out. Anybody know why I got it wrong? Maybe answer it before I finish whiting this out. I can't be in terms of x and have my boundaries in terms of y. So what am I going to do? I am going to convert this where it's y equals 10 over x. And I'm just going to flip-flop the x and y. This is going to be x equals 10 over y. Now, in reality, when you plug it into your calculator, is it going to make that big of a difference? No. If this were an AP style question and you were asked about, create an integral that represents this area and you wrote 10 over x versus 10 over y and you put dy, you wouldn't get the integrand right. So make sure you write 10 over y minus 0 or just 10 over y dy. Okay. And so that should be, once you plug it into your calculator, approximately 1.227. Let me go ahead and just show you that, just so you don't think I'm lying to you. Okay, so we'll go math 9. We'll go from 2 to 10 of 10 divided by x dx. Now remember, the x is just arbitrary. Whoops. Let me move that over a little bit. Can you see that? Not too bright there. Okay, and bada boom. Ooh, what we get there? We got to fix this. Let's see. Got 1.227. It's because I'm looking at the wrong problem on my answer key. It's not 1.227. My answer key over here, just so I can confirm, number 5, 2 to 10, is 16.094, which is what I got right here. It does help to look at the right problem, which I was not doing. So yeah, let's fix that too to be 16.094. Matches up. Good. Hey, just like the painter, Bob Ross, right? Wasn't it Bob Ross? They're not mistakes. They're just happy. Well, you guys know the drill. You guys need to let me know what that quote is. If you're listening, which maybe only a handful of you will listen, remind me of the quote next time you see me. All right. All right. And now we are on to the last section here of area between two curves with respect to y. Let's make sure we zoom in. All right, cool. Now this one's going to be the 1.227. Okay. This is our 4 divided by 2 minus x, and this is our y equals 4. So when we do this, we're looking at this area right here. Okay. I'm looking at this right now and I'm saying to myself, you know what? I really don't want to get this in terms of y. Okay. At the end of the day, let's get the area between two curves. So I'm just going to look at going from 0 to 1 in terms of x. So area equals, in this case, 0. This intersection is 1. And then it's just going to be top minus bottom. So in this case, I'm going to do 4 because the top function is that. And then minus the bottom, which is the 4 over 2 minus x dx. And that's equivalent to 1.227. Now, if you got in terms of y and you went that route, hey, by all means, double check, make sure that you get that answer. And if you don't get the right answer and you really trust yourself, let's have a discussion in class. Okay. When the directions say write a correct definite integral and find the area of each region, it doesn't say that it has to be in terms of one over the other. Okay. Both of these are in terms of y, pretty easy to see. So in this case, for these examples, especially the first two, I'm going to keep them in terms of y. So my area here is going to be right here to right there. So what are those y values? 0 to 1. It wouldn't really matter if you're in x or y. Your boundaries are going to be 0 to 1 no matter what. But in this case, we're going to go rightmost and then leftmost. So the rightmost function is going to be this right here, which is the y squared, minus the leftmost, which is the y cubed, dy. Plugging in that into your calculator, you should get 1/12. Okay. Same thing over here. You're not going to want to get these in terms of x. They're both in terms of y. We're going from 0 to 1. This is the rightmost. This is the leftmost. So setting this up, it's just going to be the integral from 0 to 1 of 12y squared minus 12y cubed minus the quantity 2y squared minus 2y dy. Plugging this into your calculator, parentheses do matter. Just be careful with it. I think you should get 1 1/3 or 4/3. Okay. This one right here, if you leave it in terms of x, you're going to need two integrals. Reason being is you have a different top function here than from 1 to 2. It's very similar to number, well, I don't have numbers, but the second row, second column on 7.1. Okay, the explanation there. I'm going to get this in terms of y, so this is just going to be x equals the square root of y. It's actually the plus or minus square root of y, but since we're just dealing with this side, it's going to be the square, the positive square root of y. And then x here equals 2 minus y. So when we look at this, we're going to say the area equals, and the reason why I want to put it in terms of y is because I just want one integral versus two. Okay, so no matter which way you go, if you do two integrals versus the one, you should get the same answer, obviously. So this is my lowest or bottom y value, and this right here is going to be my top y value. So we're going to go from 0 to 1. Rightmost function is going to be the 2 minus y, and the leftmost function is going to be the square root of y, dy. Plugging that into our calculator, you should get 5, 6. Okay. The next three examples are going to be application problems. And so I'm going to check on my daughter because she's whining right now. So I will create another video that goes over 8 and then these two examples. Okay, so give me 1 minute. All right. Actually, there's a pause button, which is kind of nice. So I'm just going to work on that instead of creating a new video. All right. So with this application problem, this is a good one that I could see being a multiple choice question, potentially something of that nature, but let's not overthink it. So College graduate has 2 job offers. Starting salary for each is 32 grand. And after 8 years of service, each will be paid 54,000. So the salary increase for each offer is shown in the figure. Monetary viewpoint only. So only looking at money. What is the better offer? Well, I think we can all agree that offer 2 here is going to be the better offer, even though future wise might be like we might be trend going up, so it looks like we're kind of able to continue this pattern if we were, but we're only looking at it from the first 8 years of service, where it looks like offer 2 you're kind of panning out and you've met kind of your peak of what you're going to be making here. But looking strictly at the monetary aspect, you've accumulated more money with the second offer than you have the first offer. So because of that, we are going to say that offer 2 is the better offer based off of the monetary viewpoint, because you have accumulated more money over that 8-year period. Okay, so offer 2 accumulated more money, and obviously explain it how you want. All right. These types of problems are kind of my favorite. I'll go ahead and see if we can work through. I might actually get a scrap piece of paper here to go over this problem, because it's going to take a little bit of time. Okay, so visually speaking, we want to try and come up with a horizontal line. Let's go. Let's get in there. Let's focus. How do we focus? Autofocus. There we go. How you doing? All right. We want to find the value b such that the horizontal line y equals b, divides the region bounded by the graphs of the 2 equations into equal area. So we're going to look at the parabola 9 minus x squared and y equals 0. So we're looking at this area right here. Okay. And we want to ask ourselves, what line will cut this area right here evenly? It'll bisect it, if you want to look at it that way. Okay. So the first thing we got to do is we got to be able to find the area from 9 minus x squared from -3 to 3. So let's find that first. All right. So looking at this, we're going to say, okay, area equals from -3 to 3. And honestly, you could say from 0 to 3 and just double it, because obviously it's going to be symmetrical. But we're looking at 9 minus x squared dx. Plug it into your calculator. I'm just going to do everything by hand just to show you that it is capable of being done by hand. So I'm going to say that this is equivalent to 9x minus x cubed all over 3 from -3 to 3. So this is going to be equal to 27 minus 9. That's plugging 3 in, minus -27 plus 9. So we're looking at 18 plus another 18, so 36. So this area right here is 36. So we get the area to equal 36, which would mean if we want to bisect this area, well, then half the area is equal to 18. All right, so that's good information to have right there. I'm just going to get rid of this worksheet so we know what the question is that we're trying to answer, right? So with that being said, we want to go ahead and say, okay, if we know that half of this area right here is going to be 18, I either can try and identify the top half of this or the bottom half. Well, if I identify the bottom half, I'm going to need, not just one, but I'm going to need a couple of integrals. So I'm going to focus on this top part right here. Okay, I'm going to look at this area that's right here to try and interpret that. Okay, so we know that the area is going to equal the integral. We'll talk about our boundaries here in a second, but the top part here is going to be your 9 minus x squared. While this line right here is going to be just b. And this is going to be in terms of x. Okay, so whatever that value is for b, it's a constant. We're just going to say that b is the constant that we're trying to find, obviously. So then this is like, okay, well, where does 9 minus x squared equal b? Because this is y equals 9 minus x squared, and this is y equals b. So I want to be able to find the x values that represent this. So I'm going to add x squared over and subtract b. So x squared equals 9 minus b. So x equals plus and minus the square root of 9 minus b. So that's what these x values are right here. This is going to be negative square root of 9 minus b, comma b. And this point right here is going to be square root of 9 minus b, comma b. So if we want, we can go ahead and say, all right, my boundaries here are going to be negative square root of 9 minus b and positive square root of 9 minus b. That equals the area. Well, what's the area? The area, in this case, is going to be 18. And I think we could actually go about this, but I kind of want to make it easier on us. So I said earlier that this is symmetrical. So instead of going from the negative square root of 9 minus b to the positive square root of 9 minus b, I'm just going to go from 0 to square root of 9 minus b and double it because it's symmetrical. So I'm going to make this 18 equals 2 integral from 0 to square root of 9 minus b, and then 9 minus x squared minus b dx. So in reality, we could make this, obviously divide both sides by 2. So this is going to be 9 equals, and I'm just going to go ahead and take the integral of this now. So this is going to be 9x minus x cubed over 3 minus bx from 0 to square root of 9 minus b. So I'm going to substitute in this info. Okay. And so, we could simplify this. I mean, I get right here, I got like terms. So in reality, I could, before I, plug it in, I could say, hey, this is going to be 9 minus b times x minus x cubed over 3 from square root of 9 minus b and 0. Do you have to do that? No, but it might make it a little bit easier. Remember, I'm plugging this in for what values? The x values. Okay. So it's going to be 9 equals, if I plug this into both, this is going to be 9 minus b times, well, this is equivalent to 9 minus b raised to the 1/2, right? So if I wanted to, I could just write it that way because, this is to the first. This is going to be 9 minus b to the 1/2 here. Hey, like bases, what do you know? Minus the quantity, 9 minus b to the 1/2 cubed. Well, if it's to the 1/2 cubed, isn't that the same as me saying 3/2 all over 3? And what do you notice here? What's happens when you multiply like bases? You add exponents. What do you think this exponent is going to be? 1 plus 1/2 is 1.5 or 3/2. So these are going to be able to be combined. We're getting somewhere. So this is 9 equals 9 minus b to the 3/2. That's a whole one of those. Minus 1/3 of 9 minus b to the 3/2. Well, one of these minus 1/3 of these is going to be left with 2/3. So this is going to be 9 equals, and we're getting close. We're almost done, so don't worry. This problem doesn't go too much further. 2/3 times quantity 9 minus b to the 3/2. So let's multiply by the reciprocal. We get 27 halves equals 9 minus b to the 3 halves. How do we get rid of that radical there, or that fractional exponent? Multiply or take the power of both sides to the 2/3. So we're going to take this to the 2/3, this to the 2/3. So we're looking at, I'm going to go up here now. Boop. Okay. We're talking about 27 over 2 to the 2/3 equals 9 minus b. Remember, our goal here is to find the b value that allows us to find the horizontal line that will give us a line that bisects this area, right? So we get this. I could add b over and subtract all that. So this is going to be b equals 9 minus 27 halves to the 2/3. I'm going to plug that in my calculator real quick. See what it spits out. Okay. So we know by looking at the graph up here that if it's 9 minus x squared, it obviously can't be greater than 9, right? That wouldn't make much sense. It's got to be in between 0 and 9 here. Okay. So if we do 9 minus the quantity 27 divided by 2 raised to 3 divided by 2. That doesn't make any sense. That should be 2/3. Sorry. See? So double checked and I made sure, oh yeah, that doesn't make any sense, right? Let's try this again. 27 divided by 2 raised to the 2/3. There we go. So we get B to be approximately 3.330, which means that up here, the line Y is approximately 3.330, bisects this area into two equal values of 18, right? So that's okay, but I would prefer it to be represented by that value because that's exact. All right. I got 2 minutes because I think these cut out at 30 minutes. So I'm going to try and rattle through this real quick. So I got a vertical line that I want to go ahead and represent. So this is y equals x. We got y equals 4 and x equals 0. So we're going to try and divide this by a vertical line x equals a. All right. So we can go ahead and say, all right, what is this area? Well, the area here, I'm just going to look at it, is going to be, height of 4, length of 4. So this values, this area is going to be 8. So half of that, it's going to be 4, I believe. All right. So we're going to say half the area equals, well, top minus bottom. Doesn't really matter which one you go to. You can go from 0 to a or a to whatever this x value is. I'm going to go from 0 to a. So from 0 to a, it's going to be top minus bottom, which is 4 minus x. I got less than a minute here, I think. So this is going to be 4 equals 4x minus x squared over 2 from a to 0. So this is going to be 4 equals 4a minus a squared over 2. Multiply everything by 2, so I get 8 equals 8a minus a squared. So a squared minus 8a plus 8 equals 0. So 17 seconds left. You got to be able to use a quadratic formula. You get a equals 4 plus or minus 2 squared root of 2, and then you're going to get the 4 minus 2 squared root of 2, which is approximately 1.172. Hopefully this helps.